So for simple calorimeter, there are two different cases. So for case number 1 is the heat of neutralizations is absorbed by both the calorimeters and the solution. So from the questions, usually we can get the informations on the solutions and also the calorimeter. So for example, this question, 100 ml of HCl mixed with 100 ml of NaOH. So from these informations, can you see that we can get the information on the solutions formed from the neutralizations reaction, whereby the volume of the solutions formed is 200 ml. Must remember this. This is the informations on the solutions, 200 ml. And there is informations for calorimeter as well, because this question given the heat capacity of the calorimeter, which is 335 joule per degree Celsius. So this is case number 1, where the neutralizations reaction release heat which is being absorbed by the solution, form, and also the calorimeter. So one thing to take note for enthalpy of neutralizations is when we do the calculation for enthalpy of neutralization, must remember that we are forming aqueous solution. So the density and also the specific heat capacity usually is assumed to be same with water. So the density of the aqueous solutions will assume to be 1 gram per ml, and the specific heat capacity of aqueous solutions is assumed to be same with the specific heat capacity of water, which is equals to 4.18 joule per gram per degree Celsius. And then for the heat or enthalpy of neutralization, we must remember that first the heat release is absorbed by the solutions first, then only absorbed by the calorimeter. So if the questions give you heat capacity of calorimeter, it means that the heat released from the neutralizations reaction is absorbed by both the solutions and the calorimeter. So how to solve this question? So to solve these questions, first we must look at the definitions of enthalpy of neutralizations first. So enthalpy of neutralizations is defined as the heat release when 1 mole of water is formed when an acid reacts with a base under static condition. So it means that first step, we must calculate the number of moles of water, because in the definition it is defined for the moles of water. So how to calculate the number of moles of water? We know that this is a neutralizations reaction. So when an acid is react with a base, usually salt and water will be formed. So and for this question, so equal molarity and volume of acid and base react with one another. So means that there is no limiting reactants in this question. So to determine the number of moles of water, we can use the informations of either the base or the acid HCl to calculate the number of moles of water. So in this question, I'm going to use NaOH. Okay, so in the question, 0.5 molar of NaOH being used and 100 ml of NaOH which is being used. And we just use the formula MV to calculate the number of moles of NaOH as 0.05 mole. Then from the balanced chemical equations, we know that 1 mole of NaOH is equivalent to 1 mole of water formed. So 0.05 moles of NaOH is equivalent to 0.05 moles of water, which is formed in this neutralizations reaction. Then we can move on to look at the second step. So the second step is also calculating the Q reaction. So remember, this is case number 1, whereby the heat released from the neutralizations reaction is absorbed first by the solution and the calorimeter, because information heat capacity of calorimeter is being given. Okay, so the equation for the Q reactions would therefore be negative Q reactions equals to the MC delta T plus C delta T. Okay, and then remember how to get the mass of solution. Remember, previously I already mentioned the solutions form has the volume of 200 ml. So, and the density of the aqueous solution is assumed to be equals to the density of water 1 gram per ml. So we just need to multiply the volume of solution with the density of water to get the mass of solution. So 200 ml multiplied by 1 gram per ml, so you get 200 gram as the mass of the solution. Then you just need to substitute into the equation to calculate the Q reaction. So this Q reaction basically is referring to the heat release when 0.05 moles of water is formed in this neutralization reaction. So how we calculate enthalpy of neutralizations? So first we need to equate 0.05 moles of water found in step 1 with the Q reactions found in step 2. Then we calculate for 1 mole of water formed, what is the amount of heat that is being released, and that is equal to the heat of neutralizations or enthalpy of neutralizations of the reactions. So now we shall look at case number 2. So for case number 2, the heat released by the neutralizations reaction is only being absorbed by the solution. So means that in the question, you cannot find any information on the calorimeter. So we shall look at the examples question. So in this question, can you see that you can only get the information on the solutions form? There is no information in terms of heat capacity of calorimeter that has been given to you. So means that this is case number 2, whereby the heat released by the neutralizations reaction is only absorbed by the solution. So how to solve this question? So again, first calculate the number of moles of water. So for this question also involve no limiting reagent because the molarity and the volume of HCl and NaOH are the same. So we can use either NaOH or HCl information to calculate the number of moles of water. So I chose to use NaOH, use the formula MV, I can get the number of moles of NaOH, and then from the stoichiometry in the balanced chemical equations, I can determine the number of moles of water. Then in step 2, I calculate the Q reaction. So this is case number 2, so no information is given for calorimeter, so the equations will just be negative Q reactions equals to MC delta T for the solution. So and the Q reaction is determined for 0.1 mole of water. So to calculate enthalpy of neutralization, first we equate 0.1 mole of water found in step 1 with the Q reactions found in step 2. And then we calculate for 1 mole of water, what is the amount of heat released in the neutralizations reaction, and that is equivalent to the enthalpy of neutralizations of the reactions.